Hi, the purpose of this video is to explain how to find the surface area of prisms or a certain polyhedra. And I wanted to start by defining different terms first. And we're going to start off with polygons because this is kind of crucial to what we're doing today. So polygon is a two-dimensional figure. It's closed and it's made up of straight line segments that connect from end to end. And the point where two sides meet is called a vertex. Okay, now these segments can't cross or else they're not going to meet at one point. Okay, so vertex is very important. Polygons are named by the number of sides that they have. Okay, so polygons with 3 to 10 sides, I'm going to kind of go over those. So first you have a triangle, which tri means 3, has 3 sides. Quadra means 4, 4 sides. Pentagon, 5, and so on. A polygon with 6 sides: hexagon, 7 septa, 8 octa, 9 nona, and 10 deca. So these are all prefixes that we've kind of known from past lessons. So we want to talk about how this figures into the three-dimensional figure. Well, those were two-dimensional figures which just have length, width, or base and height, and we can measure their areas using those 2 dimensions. So when you have a third dimension, the 3 dimensions are length, width, and height. And you may call height depth, or some people have other names for it, but we're going to call it length, width, and height for today. So when you have a 3-dimensional figure that's bounded by a bunch of polygons, and the interiors of the polygons is called a polyhedron. Okay, so those polygons are what we're going to focus on today. All right, so there are 2 types of polyhedra. One of them we're going to focus on, but we're going to identify 2. The polygons that make up a polyhedra are called faces, and where they meet is called an edge. So 2 examples of polyhedra would be a cube or a pyramid, and we're going to just sort of identify some today. Okay, so we're going to start with a rectangle. So rectangle is a 2-dimensional figure, and once we give it height or depth, we're giving it a 3rd dimension. And so that's why we call it a 3-dimensional figure. So if you look at the front rectangle of that, and the top side is also a rectangle. So if you go all the way around this polyhedron, it's just a bunch of rectangles. So those are polygons that that make that polyhedron, that enclose it. So we can call those faces. Okay, so the front rectangle is a face, and the top rectangle is a face, as well as all the other rectangles all the way around. And now the edge, see, here's the edge where those 2 faces meet, and that edge is a line segment, okay, as well as all the other edges here. Okay, so that's basically the parts of a polyhedra. Now, a prism is one certain type of polyhedra, and it's one that has 2 congruent faces, which are called bases. Okay, so they have to be congruent, but they also have to be parallel. The other faces of that prism all must be rectangles. They're usually easy to tell whether they're rectangles or not. Some are marked, some are not, but when we look for the 2 parallel bases, then it becomes a little bit more obvious. Okay, so a prism is usually named, just like a polygon, it's named by its base. So if we look at this right here, that's a triangle. That's a 2-dimensional triangle. Now once we add those, that 3rd dimension, we now have a prism. Okay, so this is a polyhedron, and we know it's a prism because if you look at those 2 triangles, that's what gives it this name. So this is called a triangular prism based on the fact that the 2 congruent parallel bases are both triangles. Now, sometimes it might be a little hard to tell, so you look at each lateral face. Okay, so I look at this face right here, that's a rectangle, but if you look on the other side of it, you don't see another face that's like it. Okay, there's no other face, otherwise it would look something like this. But we don't see that there. So we know that that's not the base. Then we look at the other lateral face, and also kind of the same concept. We don't see this. Oops, sorry, it's a trapezoid. We don't see that on the other side. So this is not the base either, nor that one. Okay, so that's what gives it its name. The two parallel bases are congruent triangles. Okay, so these two things have to happen. They have to be parallel and they have to be congruent in order to be the name of the prism, in order to be called a base. Right, so if we look at this one here, let's see if you can guess what this one is called. And this one is called, if you guessed, a pentagonal prism, you are correct, because none of these lateral faces have congruent parallel faces on the opposite side. All right, so let's move on. And those two parallel bases are pentagons. Okay, so here's the type of polyhedron that we're not going to focus on today. This is a pyramid, and what sets them apart from a prism is what we're gonna is why I wanted to introduce this. Okay, so let's say we have a rectangle here. We're looking at an angle. Now, if we have these perpendicular height leading to another rectangle that is parallel and congruent, then this would be a prism. But in a pyramid, all of the faces, all of the lateral faces, come to one vertex, including that one and that one. So you see 4 different faces, 1, 2, 3, 4, all the way around it, come to one vertex. So that means we have a base here, which is a rectangle, but we don't have another one on the other side. So one thing that sets pyramids apart from prisms is pyramids have one base, prisms have 2 bases. Okay, so, and also these are named by their bases, so this would be called a rectangular pyramid. Okay, so what would this one up here be called? It's got 1, 2, 3, 4, 5, 6 sides on the base polygon. This is called a hexagonal pyramid. Okay, so we're going to talk about how to find the surface area of a prism. Okay, so back to prisms. Now, in order to find the surface area of a prism, all we do is we add up all the areas of all of the faces. Okay, now there is a formula for this, but we're just going to focus on what exactly is surface area and how to find it by finding the sum. Okay, so first, we make sure that we count the faces on the prism, because when we're adding up all of these sides, we may forget one. So it's good to know that a rectangular prism has 6 faces. So once we add all the faces up, just kind of double check and make sure that there's 6. Okay, now these are all rectangles. And if you look kind of closely, any of these faces can be called a base, because every single one of these faces has a congruent and parallel face on the other side. So that can be the base, or the top one can be a base, so the front one can be a base. So in a rectangular prism, you can choose any one and call it the base, but it doesn't really matter because we're just going to add the areas anyway. So let's do this step by step. So first, we look at the bottom face. We'll call that the base. And remember that the area of a rectangle is just length times width, or the base times the height. So we would get 6 times 2, which is 12 square feet for the bottom. Now, since the top, we already know it's congruent and parallel, so it would have the same area. So we just add that in. Okay, looking at the side, we have a 5-foot height and a 2-foot width right here. So that would give us 10 square feet. And then the opposite side, also parallel, also congruent. We're just going to copy that down. And then the front would be 6 feet by 5 feet. And that would give us 30. Opposite side, 30. Okay, now before we add them, make sure again you have 1, 2, 3, 4, 5, 6 sides. So now we could find the sum and add all those up. You get 104 square feet. Not too bad. All right, so let's look at a triangular prism. Okay, now again, remember the safe bet is to count all the sides first. We have 1, 2, 3, 4, 5 on the opposite side. So 5 faces. And let's find the areas of them. So we know it's a triangular prism, so the triangle is the base. So the dimensions are 3 by 4. The base is 4, the height is 3. And there's the one on the opposite side, which has also a height of 3 and a base of 4. So you got to remember, don't just multiply the base times the height or the length times the width. In this case, it's 1/2 base times height for the formula to find the area of a triangle. So when we take the area of one of those triangles, it's 1/2 times 4 times 3, which is a 6 square foot area. And then the opposite side, we're just going to copy that down. Okay, so we just took the 3, the height, and the base, multiplied them, and cut it in half. Okay, you can also divide by 2, but same result. Okay, so then we look at the left side, and those dimensions are 3 by 8. Okay, so remember this is a rectangle because it's a prism. So if this is 8, then we can assume that this is also 8. Okay, that's 4. This is also 4 because again, it's a rectangle, and this is 3. So we're going to look at that side. So it's 3 by 8, which is 24 square feet. And then the top side is 5 by 8, which is 40 square feet. The bottom is 4 by 8, which is 32 square feet. And then make sure that's 1, 2, 3, 4, 5 faces. Now we can add them up, and we get 108 square feet. Okay, so a triangle isn't any different from a triangular prism isn't different from a rectangular prism as far as finding the surface area, but the only difference is the area of the base. We've got to remember those polygon formulas for the area of the polygons. So we're going to look at a different type of prism. This is a trapezoidal prism. And again, there's a trapezoid and there's its congruent base. Okay, so that trapezoid and that trapezoid parallel and congruent. No other faces have that. So do you remember the area of a trapezoid formula? Well, it's an important thing because we're not just going to multiply base times height. Trapezoid is 1/2 times the sum of the bases times the height. Okay, in other words, the average of the two bases on that trapezoid, and remember the bases are the parallel sides of the trapezoid, and you multiply it by the height of the trapezoid. Okay, so let's look at the first one. Now, we have a base of 10, but this one's not marked. What is that one? So just keep in mind that these two faces are congruent. So if this smaller base is 4, so is that one. So we can now plug in the formula. So 1/2 base 1 plus base 2 times the height, which is 2, and we get 14 square feet. Okay, so the sum of the two bases is 14. Okay, so now that's the area of one of the bases. Since this is a prism, the other one is congruent, so we're just going to copy that down, 14 square feet. So now we have the two bases. We're just going to now calculate the area of all of the rectangular faces, the lateral faces. So start with the side. That is 3 by 7. This side is also 3 by 7 because that height is 7. Now, another way of thinking of the height is the distance between all of the two bases. Okay, so the two bases, how far apart they are, is going to be the height all the way around. Okay, so this is 3 by 7 also. And then the front, you have 4 by 7. All right, so make sure you don't forget the back side. I almost forgot it. So that's 10 by 7, which is 70 square feet. Okay, so make sure you have all the sides. 1, 2, 3, 4, 5, 6. 6 sides. Okay, you add them all up and you get 168 square feet. All right, so that one's a little bit more complicated, but for the only reason is the area of a trapezoid, something you need to have memorized by now. Okay, we're going to look at something a little bit more complicated, and that is an irregular prism. Now, an irregular prism is a prism that doesn't have a base that's a regular polygon. Okay, this is a rectangle. That's not the base because opposite side. Look at the opposite side. So none of these rectangular faces have parallel and congruent sides, faces. Sorry. So we're going to look at the front side. Okay, that front side has a parallel and opposite side, and that's an irregular shape, kind of L-shaped. So we count the sides here. There's 8 sides. So here's the one that is the base. Okay, because if you look at the opposite side, that's congruent, that's parallel. The other side is hidden, so it's going to take a little bit of the imagination to see it. All right, so how are we going to find the area of that face, which is the base? We don't know this formula of an L-shaped polygon, so we're going to do what we did with irregular polygons. We're going to break it up into measurable polygons. All right, so I think the easiest way would be just to cut it that way. So let's look at the dimensions. Okay, this side would be that side, which is 9. And then the width would be this 9 here, giving us 81 square feet for this part. Okay, so that little square is 81 square feet in area. All we need to do is find this area. All right, so let's look at our other dimensions. We know the length of this is corresponding with that one, so that's 15 feet. But what about this part right here? We don't see this measurement. Okay, we don't know what this is. Okay, because that's not marked on the original figure. So we look at this measurement here, which is 15, and this one here, which is 9. Okay, now these are all right angles, so these are all rectangles. So we got to find what you add to 9 to make it 15, right? And that's how we get that side right there. Okay, so that side is 6 feet. Okay, and again, in case you missed it, it's because 9 and 6 is 15. All right, so when we multiply those, we get 90 square feet. So now we can add those two to find the area of that polygon, and we get 81 plus 90 is 171 square feet. So now we have the area of the base set at 171. So now we look at all the faces in this polygon. First one is 171 square feet. There's the work. Then the opposite side, congruent, so we're going to copy it. Okay, so now we're just going to make sure that we count all of the lateral faces, which we counted at the beginning, and we counted 8 faces in total. So the first lateral face, that is 4 by 15, 60 square feet. Top one, 6 by 4, that's 24. Okay, then we're looking at the hidden one that we can't really see. That is 4 by, and then we do have to do another calculation here, and that's 6. Okay, and again, 9 and 6 will give us this 15 here. Okay, so that's 24 square feet. And this other one, lower one facing up, is 9 by the height, which is 4. That's 36 square feet. And then this is also 9 by 4, which is the height. Okay, and remember, the height is the distance, always the distance between the two bases. All right, and then the bottom would be 15 by 4, which is 60. And then make sure we have all 8 faces. 1, 2, 3, 4, 5, 6, 7, 8. We got them all. And now we can add them to get 582 square feet. Okay, so hopefully this helps with finding the surface area. Again, this is the one way, introductory way of finding it without using the formula. This is just adding all of the faces. Thanks for watching.